Hello once again. I explained in the previous video about sectors and segments, which are part of a sector, because a sector is made of an isosceles triangle and a segment. Now, this is a circle, as you can see, and I'm pointing with my cursor. I hope that you can see my cursor here on the screen. This red point in the middle is called the center of the circle, and A is a point on the circumference of the circle as well as B. Now, the distance between 2 points on the circumference of the circle without passing through the center, such as A and B, this distance is called a chord. The length of this chord, as it is given to us in the question, is 8 centimeters. So let's place this on the drawing. The radius, which is the distance from the center to the circumference or to any point on the circumference, such as A, is called the radius, and it's equal to 5 centimeters as it is given to me in the question. And once again, the distance from the center to a point on the circumference, such as B, is called the radius, and the length of it, as it is given to us in the question, is 5 centimeters. So now we have a sector. Before we have a sector here, as you can see, if we name this the C for center. So A, B, C is a sector, where inside this sector there is an isosceles triangle and a segment. If we draw a line from apex C, or from the center down to the chord and perpendicular on it, as following, it's gonna cut the chord. Let's call it as H. It is perpendicular on the chord, so this angle is 90 as well as this angle, and it's going to cut or to bisect the chord into 2 equal pieces, such as 4 and 4, because the whole chord is 8. So once again, if we draw a line from apex C, or from the center of the circle down to chord AB, as following, and let's name this distance of chord AB to the center of the circle as H. The angle, as I explained, the line from the apex or from the center of the circle down to the chord is perpendicular on the chord. So this angle is 90 as well as this angle. And this line we draw from the center down to chord AB is gonna bisect it into 2 equal pieces. So if it is 8 centimeters long, it's going to be 4 and 4. So once again, we have sector ABC. Inside the sector, we have an isosceles triangle ABC, and we have a segment. The length of the chord is known, as well as the radius of the circle, and what they're asking for is the distance of chord AB, or how far is chord AB from the center of the circle. So they're asking for the length of H, basically. So we have to look for triangles, and as you can see here, we have an isosceles triangle and we have 2 right angle triangles, AEC and BEC. So once we have the triangles, we can always use, especially if they are right angle triangles, we can use Pythagorean theorem. We can use sine or cosine or tan of angles to find a missing side or a missing angle. So in the right angle triangle AEC, and always remember please that the right angle or the 90-degree angle is placed in the middle. The alphabet of the right angle or of the 90-degree angle is always placed in the middle when we name the right angled triangle. So it is AEC, triangle AEC, or triangle CEA. The hypotenuse is 5 and side AE is 4 because it is part of the chord AB. So the unknown side is H or side CE. So we're going to use here the Pythagorean theorem, which states that the hypotenuse to the power of 2 is equal to the addition of the two perpendicular sides, each taken to the power of 2. So side AE, which is 4 to the power of 2, plus our unknown side, which is side CE, so it's going to be h to the power of 2, and the hypotenuse is 5, so 5 to the power of 2 is equal to 4 to the power of 2 plus h to the power of 2. You really don't need to find that 4 to the power of 2 is equal to blah blah blah, although it's easy to know it here, but just start immediately with applying opposite operations, because we know that 4 to the power of 2 is a number. So we are trying to find h. We are trying to make h the subject. So by subtracting 4 to the power of 2 from each side of the equation, so it's going to be h squared is equal to 5 squared minus 4 squared. Don't use the calculator yet. We're not finding h squared, we're finding h. So we're going to square root each side. So it's going to be h is equal to square root of 5 squared minus 4 squared. Now this is ready to be inserted in the calculator, and if you do so, h is going to be 3 centimeter long. So that's how we found the distance of chord AB, or how far the chord AB from the center of the circle. If you look at this question, I would like you to try on solving it on your own, but I'm going to help you a little bit with the given numbers in the question and how can you place it on the drawing. So what's saying over there that this is a pipe, and what's shaded in pink is the level of water, and the level of water, so this is the center of the circle, and this is the radius because it's the distance from the center to any point on the circumference. So this is the radius of the circle, which is not given to me in the question yet. The radius is given to us as 7, and the depth of the water is given to us as 2 in the question. So the distance of the chord to the center of the circle is equal to 7 minus 2, which is equal to 5 centimeter. So we know the length of the radius, we know the depth of the water, we know the distance of the chord to the center of the circle, and we're going to look immediately to our sector. So if we connect between the center and the point of the level of water, which is a point on the circumference of the circle, so this is the radius, and if we connect between the other point of the the other point of the level of water in this pipe to the center. This is the radius as well. So as you can see, we always look for the sector. Inside the sector there is the isosceles triangle and the segment, and we have the given numbers in the question. So I'm gonna leave this question for you to think of it. Please, if you struggle with any of the steps, you can always leave a comment on this video, and I will get back to you. And there is a video posted on how to solve this question in particular. Please watch this video again if you struggle with any of the steps of finding the distance of a chord from the center of the circle. And I'm gonna thank you at the very end of this video for watching and for sharing the link of this video and for subscribing to my YouTube channel.